In this outcome, you'll learn to work out the formulae of common ions and the compounds they form, and then to write full balanced chemical equations complete with state symbols. It's the practical grammar of chemistry, and once it clicks, it becomes second nature. Here's what you'll be able to do by the end. You'll predict an ion's charge from its group in the periodic table, and link that charge to electronic structure and the noble gas idea. You'll name and write formulae for common ionic compounds, handle polyatomic ions like sulfate and ammonium correctly, and put together full balanced equations with state symbols: solid, liquid, gas, and aqueous. Let's start with why atoms form ions in the first place. An atom is neutral, its protons and electrons balance, but if it loses or gains electrons, it becomes charged, and we call that an ion. Atoms do this to reach a full outer shell, like the nearest noble gas. Metals lose their outer electrons to form positive ions, called cations, while nonmetals gain electrons to form negative ions, called anions. The size of the charge simply tells you how many electrons were lost or gained. A few definitions to anchor things. An ion is a charged particle formed when an atom loses or gains electrons. A cation is a positive ion formed by losing electrons. An anion is a negative ion formed by gaining them. An ionic compound is made of oppositely charged ions held together by electrostatic attraction, and electronic structure, as before, is just the arrangement of electrons in shells. For metals, the group number tells you the charge directly. Group 1 atoms have one outer electron, which they lose to form a 1+ ion. Think lithium, sodium, and potassium. Group 2 atoms have two outer electrons lost to give a 2+ ion, like magnesium and calcium, so the number of outer electrons is exactly the size of the positive charge. Nonmetals work by gaining electrons instead. Group 6 atoms need two more electrons to fill their shell, so they form a 2- ion, like the oxide ion and the sulfide ion. Group 7 atoms need just one, forming a 1- ion, the halides, fluoride, chloride, bromide, and iodide. A handy rule is that 8 minus the group number gives you the size of the negative charge. Let's lay the two sides out together. On the positive side, Group 1 metals form 1+ ions like sodium and potassium, and Group 2 form 2+ ions like magnesium and calcium, all by losing electrons, and they keep the element's name, so sodium ion. On the negative side, Group 6 form 2- ions like oxide and sulfide, and Group 7 form 1- ions like chloride and bromide, all by gaining electrons, and their name changes to end in -id. Let's use electronic structure to explain why sodium forms a 1+ ion. A sodium atom has 11 electrons, arranged 1s2, 2s2, 2p6, 3s1. There's just that single electron in the outer 3s shell. Lose it, and the outer shell is emptied, leaving 1s2, 2s2, 2p6, exactly the same as neon, a stable full shell. With 11 protons but now only 10 electrons, the overall charge is 1+. So sodium loses one electron to become the sodium ion. Now oxygen, which forms a 2- ion. An oxygen atom has 8 electrons, arranged 1s2, 2s2, 2p4. Its outer shell holds 6 electrons but has room for 8, so gaining 2 fills it to 1s2, 2s2, 2p6, again the same as neon. With 8 protons and now 10 electrons, the overall charge is 2-, so oxygen gains 2 electrons to form the oxide ion, O2-. Let's get the naming straight. Metal positive ions simply keep the element name, so sodium ion, calcium ion. Single non-metal ions change their ending to -ide. Oxygen becomes oxide, sulfur becomes sulfide, and fluorine, chlorine, and bromine become fluoride, chloride, and bromide. Chloride, bromide, and iodide together are known as the halides. Here's the core skill: building a formula by balancing charge. An ionic compound is always overall neutral, so the total positive charge must equal the total negative charge. Write each ion with its charge, then work out how many of each you need. A handy shortcut is to swap the size of each charge to become the number of the other ion, then cancel down to the simplest whole number ratio. And remember, the charges themselves never appear in the final formula. Let's write the formula for magnesium and chloride. Magnesium is a 2+ ion and chloride is 1-. One magnesium carries 2+, but each chloride carries only 1-, so we need 2 chloride ions to balance a single magnesium. Checking that, +2 + 2 lots of -1 comes to 0, nicely neutral. So the formula is magnesium chloride, MgCl2. Let's pause and test yourself. First, what charge would a potassium ion carry and why? Second, name the ion S2- and say which group it comes from. Third, write the formula for the compound of the sodium ion and the oxide ion. And fourth, explain why aluminium in aluminium chloride needs 3 chloride ions. Have a go before moving on. Some ions are made of a group of atoms carrying an overall charge, and we call these polyatomic ions. They stay together and behave as a single unit in reactions. Hydroxide, OH-, and nitrate, NO3-, each carry 1-. Carbonate, CO3 2-, and sulfate, SO4 2-, each carry 2-. Phosphate, PO4, carries 3-, while ammonium, NH4+, is a positive one. These are well worth learning by heart: names, formulae, and charges. Let's define a few of those. A polyatomic ion is simply an ion made of more than one atom, like sulfate. Hydroxide is OH-, the ion found in alkalis such as sodium hydroxide. Sulfate is SO4 2-, a 2- ion of sulfur and oxygen. Nitrate is NO3-, a 1- ion of nitrogen and oxygen. And ammonium, NH4+, is a positive polyatomic ion carrying 1+. When you need more than one of a polyatomic ion, you use brackets. Put the number outside, just after the closing bracket, and it multiplies everything inside. So calcium hydroxide, Ca bracket OH bracket 2, means 1 calcium 2 plus with 2 hydroxide ions. You only need brackets when you've got 2 or more of the ion. A single one, as in sodium hydroxide, needs no bracket at all. Let's write the formula for calcium and hydroxide. Calcium is 2+ and hydroxide is 1-, so we need 2 hydroxide ions to balance 1 calcium. Because there are 2 of them, we enclose the OH in brackets. Checking the charge, +2 + 2 lots of -1 is 0. So the formula is calcium hydroxide, Ca bracket OH bracket 2. Now ammonium and sulfate. Ammonium is 1+ and sulfate is 2-, so we need 2 ammonium ions to balance 1 sulfate. Since there are 2 ammoniums, we put NH4 in brackets. Checking, 2 lots of +1 + 1 lot of -2 is 0. So the formula is bracket NH4 bracket 2 SO4, ammonium sulfate. This one's a little trickier: magnesium and phosphate. Magnesium is 2+ and phosphate is 3-. The lowest number both 2 and 3 divide into is 6, so we need 6 units of charge on each side. 6 divided by 2 gives 3 magnesium ions, and 6 divided by 3 gives 2 phosphate ions. We bracket the PO4 because there are 2 of them. Checking, 3 lots of +2 plus 2 lots of -3 is +6 - 6, 0. So the formula is magnesium phosphate, Mg3, bracket PO4 bracket 2. Here's a reference set worth memorizing. On the positive side, sodium and potassium at 1+, magnesium and calcium at 2+, and ammonium at 1+. On the negative side, chloride, hydroxide, and nitrate at 1-. oxide, sulfide, sulfate and carbonate at 2-, and phosphate at 3-. Keep this list handy. Almost every formula you'll write is built from these. A full equation can also show the physical state of each substance. We use solid, liquid for a pure liquid, and gas. Aqueous, written AQ, means dissolved in water. These go in brackets straight after each formula, so sodium chloride aqueous means sodium chloride dissolved in water. Do watch the difference between liquid, a pure liquid, and aqueous, something dissolved in water. They're not the same thing. Balancing equations rests on one principle. Atoms are never created or destroyed, so the number of each type of atom must match on both sides. First, write the correct formulae, and then never change them. You balance by placing big numbers in front of the formulae, counting each element on both sides and adjusting those big numbers until everything matches. Finish by adding the correct state symbols. Let's balance solid sodium reacting with chlorine gas to make solid sodium chloride. Unbalanced, its sodium plus chlorine goes to sodium chloride. Chlorine comes as a molecule of 2 atoms, so there are 2 chlorine atoms on the left. Put a 2 in front of the sodium chloride to get 2 chlorines on the right, but that now needs 2 sodiums, so put a 2 in front of the sodium as well. Counting up 2 sodium and 2 chlorine on each side, balanced. So it's 2 sodium solid plus chlorine gas goes to 2 sodium chloride solid. Now a neutralization, sodium hydroxide solution reacting with hydrochloric acid. An acid plus an alkali gives a salt plus water. So the formulae are sodium hydroxide plus hydrogen chloride goes to sodium chloride plus water. Counting atoms, 1 sodium, 1 oxygen, 2 hydrogen and 1 chlorine on each side. It's already balanced. For the states, both reactants are in solution, so aqueous. The salt stays dissolved, also aqueous, and the water formed is a liquid. So sodium hydroxide aqueous plus hydrochloric acid aqueous goes to sodium chloride aqueous plus water liquid. Let's balance solid calcium carbonate reacting with hydrochloric acid. The products are a salt, water, and carbon dioxide gas, so calcium carbonate plus hydrogen chloride goes to calcium chloride plus water plus carbon dioxide. Calcium chloride needs 2 chlorines, so put a 2 in front of the hydrogen chloride. Recount 1 calcium, 1 carbon, the 3 oxygens split as 1 in the water and 2 in the carbon dioxide, 2 hydrogens and 2 chlorines, all balanced. Add the states, solid, aqueous, acid and salt, liquid, water and gas, and you get calcium carbonate solid plus 2 hydrochloric acid aqueous goes to calcium chloride aqueous plus water liquid plus carbon dioxide gas. Finally, a precipitation reaction, barium chloride solution with sodium sulfate solution, forming an insoluble barium sulfate. The formulae are barium chloride plus sodium sulfate goes to barium sulfate plus sodium chloride. The sulfate stays as 1 unit, 1 on each side. Fine. There are 2 sodiums on the left, so put a 2 in front of the sodium chloride. Recount 1 barium, 2 chlorine, 2 sodium, and 1 sulfate. Balanced. The insoluble product is a solid and the rest are aqueous, so barium chloride aqueous plus sodium sulfate aqueous goes to barium sulfate solid plus 2 sodium chloride aqueous. A few common mistakes to steer clear of. Never change a formula to balance an equation, only ever add numbers in front. Keep polyatomic ions whole, treat sulfate as a single unit. Remember your brackets when a polyatomic ion appears more than once. Don't write charges in the final compound formula. Always check every element balances before you add the states. And don't confuse liquid, a pure liquid, with aqueous, something dissolved in water. Time to check your understanding. First, write the formula for potassium carbonate from the potassium ion and the carbonate ion. Second, balance magnesium plus oxygen goes to magnesium oxide, then add the state symbols. Third, what's the difference between the symbols for a pure liquid and for aqueous? And fourth, why must you change the big numbers, not the small subscripts, when balancing? Work through each one.